All right, so 3.3, day 2, we are going to learn how to divide polynomials using synthetic division. So remember last week we did long division. Synthetic division, I say it's the fun way because it's a lot quicker. When we learned it, most people are like, well, why didn't we do this before? Well, we can only use synthetic division in certain situations. So with synthetic division, you can use the factors to divide, but if you're giving something in factor form, you have to solve for x by setting the factor equal to 0. And you can't use synthetic division in every situation. You can only use it if the divisor has the form x minus c. So that form x minus c means the coefficient of x is 1, and it's linear. So this is kind of similar to completing the square. Remember how completing the square, the x squared value had to have the coefficient of 1? This is similar. And then when you're using synthetic division, you still need to write your remainder over the divisor, so over the entire factor. Another thing you have to do is use 0 as a placeholder for missing terms. Remember how we did that with long division? The same thing is going to be true with this. And in some cases, you'll see when you're doing your practice today, you might have multiple placeholders. So we'll talk about that as well. Okay, so for the first one, we're going to do that together. It's something new that you haven't done before, so we're going to take the first one slowly. And then when you are doing this on your own, if you forget the steps, I've written them down right here for you. Okay, so based on what we did last week, we know that this is the divisor. Do you guys remember what this one's called? This one here?
Dividend.
Yeah, dividend. Good. Okay, so what we have to do is set the divisor equal to 0 and solve for x. Okay, so the divisor is x minus 1/3. So if we set that equal to 0 and solve, sorry, I didn't say that too well. Then we are going to add 1/3 to both sides. X is going to equal 1/3. Okay, so what we do to set up the synthetic division is whatever we solve for here goes on the outside. So we're going to put the 1/3 right here. Okay, so now we've done step 1. Step 2, when we set up the synthetic division, we have to set up the coefficients, and the coefficients are going to be of the dividend. Okay, so the coefficients come from your dividend. So by coefficients, I just mean the values in front. So the largest one is x squared. Again, make sure that this isn't standard form. It is here. So we're going to have 3. The next coefficient is 9. And then the last one, which is the constant, is -2. Okay, your first step is always to drop the leading coefficient. Okay, so your first step, drop the leading coefficient. And then we do a series of multiplying and adding, just like what we did with long division. So we're going to do 3 times 1/3. So we're going to multiply by the divisor, which in this case is 1/3. What's 3 times 1/3? 1. So that's going to go here. Okay, and then what we're going to do from there is add straight down. So 9 plus 1 is 10. Then the process starts all over again. We're just going to repeat that till all the spaces are filled. Okay, so 10 times 1/3, we're we're going to leave it as 10/3. And then when we add these together, we want the denominator to be the same. So if this denominator is 3, this denominator is 3, what's the top going to be? -6. All you have to do is 3 times -2, right? And then when you're adding fractions, you're going to, how do we add fractions?
Add the top one.
Yeah, add the top ones. So -6 plus 10 is 4. And then what's the bottom?
3.
Stays the same. Okay, now circle that. This is your remainder. Okay, what we do is we work our way backwards. So there's the remainder, then there's the constant term, which I'm going to just call like the constant number. This is the number sign. And then this is going to be the coefficient of your x term. So when you're doing synthetic division, your answer is going to look like just like it did when we did log division, okay? So this is going to be 3x plus 10, and then, I know this looks a little strange with the 4/3 on top, but because it's a fraction, that's what we're going to do. And then you put it over the divisor, so the x minus 1/3. Okay, now for this one, set it up the same way. So the first step is always taking this divisor, setting it equal to 0. So you subtract 2 from both sides. So the -2 is going to go here. And if you want to underline it, you can. You don't have to. Okay, but when you are setting up your coefficients, you have to use 0 as a placeholder for missing terms. Okay, so whether it's a constant, okay, whether there's 2 missing terms, you have to use that. So the highest one is x to the 4th. So we're going to start with 3. So we put the coefficient of x to the 4th here, then x cubed, then x squared, then x, then your constant term, okay, and we're going to fill those in. Okay, so Rashawn, what's the coefficient of x cubed?
-1.
Good. Danny, what's our coefficient for x squared?
0.
0. Okay, so there's no x squared term, right? So you have to use that as a placeholder. You have to do that, okay? Even if the placeholder is a constant, you have to put it in. Okay, so 0 is a placeholder for any of the missing terms. Okay, and then for x you have 5. For your number you have -1. Make sure if there's a negative in front that you take that. All right, do you guys want to do this one together? Or you think you can try the first step on your own? Jack, remind us what the first step is. What do we do first? Yeah, you got to drop the first one. And then do you guys think you can do the rest of that one? So once you drop it, now we're going to multiply, right? So 3 times -2 should be -6. And then we're going to add straight down. And then we're just going to keep repeating that process. And then see if you can write out the entire solution. And if you want to just think about what the solution is, Remember, you always circle that last one. All right, so remember, negative times a negative is going to be a positive. 0 plus 14 is 14. Do the process again. So you're always multiplying here, and then you're adding straight down. Multiplying here, adding straight down. You just got to pay attention to the signs. And then I always label mine, starting at the back. So here's my remainder. This is my constant, my x squared, my x cubed. Okay, so then my final answer is 3x cubed minus 7x squared plus 14x minus 23, and then the 45 goes over x plus 2. Now, in between the remainder and the constant, don't forget that you have to have your plus there. So that does need to be plus. Okay, do you guys remember when it's going to be minus from last week? If the remainder is negative, yes, then you can use the minus. Okay? All right, and then go ahead and do part C. Let's actually add a part D in there. Let's make this 3x squared minus 8x divided by x minus 2. Do this one too. Oh, did you guys write it over there? You can just sneak it in here. Sneak it wherever you want. Both of these will be special cases. Something different will happen in each one. Okay, so I don't need any placeholders here, but make sure that you are doing the opposite. Like if it's x minus 2, when you solve, you get 2. So you have 3, negative 8, and 4. Drop down the 3. Okay, and then Jack, what goes in this space here? Yep, which is? Good. Okay, and then add straight down. Ava, what do we get there? Good. Okay, Aiden, what do I get in my next spot? Good, which means my remainder is 0. So if your remainder is 0, when you're writing out your solution, it's just going to be 3x minus 2. Okay, so it's okay if you don't have a remainder. It's just going to be the 3x minus 2. Now, the reason why I asked you to do this one as well is because if you're missing a constant, this would be 3, negative 8, and you have to put a 0 here. Use a placeholder for the missing constant. You have to. Okay, and then again, this was x minus 2, so we know this is going to be 2. So 3 times 2 is going to be 6. We have negative 2 here. This is negative 4. When you add together, this is going to be your remainder. Okay, if you didn't have that, then it would change this. So this is your number, this is your x term, so this is going to be 3x minus 2. And now you can do minus 4 over x minus 2. You could also do the plus or negative. Either one of those are fine. Yes?
So like when writing your final answer, why would
Yeah.
it be like 3x squared for like C because you like have that?
Yeah, so when you are dividing, remember that just like we did with long division, when you're dividing, when you have 3x squared divided by x, what's really happening is you're having an x cancel out with that one, so it should always be a degree less. And then when you're rewriting it, you're starting from the back. So the last one is the remainder, then the constant, then x and x squared. And since we don't have another position there, we just have the x. Okay? And yeah, if this, well, that has to be linear for this. But anytime, you can always look at the first one in each, and if you divide those, that should give you the degree. All right, now we're going to talk about synthetic substitution and the remainder theorem. So synthetic substitution is very similar to synthetic division, and it also has some important uses here. Okay, so we can use synthetic division to evaluate polynomials for a given value. Okay, so remember, when you're evaluating, you're finding that value, you're finding that number. Okay, and this process is called synthetic substitution. Okay, so not synthetic division, but some synthetic substitution. One thing we want to make sure that we understand is that the solution of synthetic substitution is interpreted differently than that of synthetic division. Okay, and we can explain this using the remainder theorem below. Okay, so the remainder theorem, we're going to go over this box together. So if you guys remember in geometry, you often had theorems, right, that seemed a little confusing at first, and then when you walk your way through them, we can interpret what that means. So this says, if the polynomial function p of x is divided by x minus a, then the remainder r is p of a. That seems like a lot of arbitrary values that we don't understand a lot about right now. So we're going to work our way through that, and we're going to talk about what each one of those means. Okay, and then we're going to talk about what this can replace. So the first thing is it says if the polynomial function p of x. Okay, so what is p of x? It really just is your polynomial function which we can think about it as our given equation. So p of x is just that polynomial function, that given equation. And if you sneak down to part A, you can see p of x equals 2x cubed plus 5x squared minus x plus 7. That's your p of x. Okay, so that's the polynomial function, the given equation. Okay, now to figure out what p of a means, let's first make sure we understand the x minus a, right? If you have x minus a, that's your divisor that you set equal to 0. And then if I were to solve that for x, what would x equal? A, because we're going to add a to both sides. Good. Okay, so a is our input value. Okay, if a is our input, p of a is our what? It's our output when you plug in a. And that's what we're going to write down there. Okay, so the term P of A means, P of A, there's actually two different things. So P of A is the output when you plug in your value of A. Okay, and I'm going to give you some examples of that. So we've actually done this before. We've just used f of x, right? So remember where we had some of the story problems where we had to find like f of 200? Or like when you were using your vertex, f of 1/4, we had to plug those in. That can be kind of long. We can use synthetic division to help us with that, to make the process a little quicker. Okay, so P of A is the output when you plug in A. It's also something else. Let's use this example. So you're dividing this value, okay, this would be your P of x, by x minus 3, okay, in this case your 3, that would be your A value, or your x value, both of them. Okay, and then when you do synthetic division, this number 7 here, that's your remainder. We'll look and see how that is interpreted in the answer. So this is P of 3 equals 7. Okay, so that's our A value, and that's going to equal your remainder. So P of A is also the remainder when you perform synthetic substitution. So remember I said that your answer is going to look a little bit different. So when you are writing your solution for synthetic substitution, it's going to be P of 3 equals 7. So P of your A value equals the remainder. Okay, so P of A equals your remainder. That's how we're going to write it. Okay, so let's apply this to example 2. Example 2 says to use synthetic substitution to do the evaluating, and you are going to have a given value for these. So your given value here is x equals 2. So if they don't give that to you in factor form, you can just use the 2. Okay, so I want you to do the synthetic substitution. You can do that for both of them. And then see if you can write out your solution, okay? And then I'm going to give you the next thing that we're going to do. Alright, let's see how the first one went. Emmy, will you tell me what your coefficients are for the first one?
2, 5,
Nice. Okay, so we're going to drop the 2 and then multiply. 2 times 2 is 4, 5 plus 4 is 9, 9 times 2 is 18, negative 1 plus 18 is 17, 17 times 2 is 34, 34 plus 7 is 41. Okay, so your solution, remember this is your remainder, so this is P of 2 equals 41. for part B? So are you done with part B? So this is another one where you're given the negative 1/3. Okay, and then Lizzie, will you tell me what your coefficients are going to be for this one?
6, negative 25, 0, negative 3, and 5.
Good. Okay, so you have to put that 0 in because you don't have an x squared term. Okay, now don't be scared that this is a fraction. This actually works out really nicely, right? Because they're all multiples of 3. So when you're multiplying by negative 1/3, it's the same thing as dividing by what? Negative 3. So 6 divided by negative 3 is negative 2. Add straight down, negative 27. What's negative 27 divided by negative 3? Positive 9. So 0 plus 9 is 9. 9 divided by negative 3? Negative 3. Just make sure that when you're adding, you keep the negative here. So you get what? Negative 6. Negative 6 divided by negative 3 is 2, positive 2. So you add, you get 7. Okay, so then your solution is just P of negative 1/3 equals 7. Okay, and then keep this. We are going to write our homework down there, but I wanted to combine the first part of 3.4 with this. So we're going to do the title and objective tomorrow. Today we're just going to do this factor theorem because it goes with exactly what we've been doing today. Okay, so today we are going to talk about the factor theorem that says for any polynomial p of x, okay, x minus a is a factor. So for any polynomial p of x, x minus a is a factor of p of x if and only if, do you guys remember those statements from geometry? You guys remember what they're called? Does anybody? You guys remember some of the statements that you learned about? Like what? Yeah, the if-then, what was that called? You guys don't remember any of them?
Is that like proofs or something?
No. Oh yeah, Gwen and Seth, I can pick on you too. I was looking for people I had. You remember this? If-then, the if-then statements. If P then Q, if Q then P. What are those called? Come on, Seth. Oh, the if-then. Remember converse, inverse? I just said that. Contrapositive, conditional. This one is the biconditional. Biconditional, because it's true forwards and backwards. All right, so if x minus a is a factor, okay, then p of a equals 0, which is the remainder. Okay, so remember we just talked about p of a, we just defined it. P of a is the remainder when you do synthetic substitution. That's what we wrote down. Okay, so write what this means in your own words below. Basically, all this means is the binomial is a factor when you divide, and the remainder has to be 0, which makes sense, because if the remainder is 0, that means it divides into it evenly. Okay, so write what this means. It just means a binomial is a factor of the polynomial if when you divide, the remainder is 0. Which really, that's how factors work, right? 3 is a factor of 6 because it goes into it evenly, twice, with no remainder. Is 3 a factor of 7?
No.
No, because it doesn't go in there evenly. Is 3 a factor of 9? Yes, it goes in there evenly. So it's the same thing, except now we have polynomials. So what we have to do is determine whether the given binomial is a factor of the polynomial p of x. Okay, well, it says that it is a factor if when you divide, the remainder is 0. So guess what we're going to do? Divide. And what are we going to look for? Yeah, all you have to do is divide and see if r equals 0. That's all we have to do. Okay, and that's what we've been doing all day today. So step 1, look how they list these out. So they're saying determine whether the given binomial is a factor. So here's the binomial. Okay, is that a factor of p of x? Okay, so with the binomial, if we're going to do synthetic division, we have to set it equal to 0. So x equals -1. Okay, and then step 2 is going to be the synthetic substitution, or synthetic division. Really, either one is fine. And then we are changing b. I know sometimes you guys like to work ahead of me. We're changing this to plus. Okay, so I want you to set it up. So we found the -1. Okay, and then Dylan, will you tell me what your coefficients are?
I had 1, -3, and 1.
Good. Okay, so we didn't need any placeholders here. All right, and then 1 times -1 will be -1. This will be -4 times -1, which will be +4. Okay, so this is the remainder. Is it 0? No. Okay, so this is how you're going to write your final answer. Since r does not equal 0, x plus 1 is not a factor. Okay, and then for part B, change this to plus. Change this one to plus. So the same step where x is equal to -2. Then we're going to do the synthetic substitution. Okay, and Dane, tell me what the coefficients are going to be for this one.
3, 6, 0, -5, -7.
Good. Okay, so don't forget your placeholder. It will now give you the same final answer. Okay? And then look what happens with this one. 3 times -2 is -6, so that's 0. Anything times 0 is 0. 0 plus 0 is 0. 0 times -2 is 0. -5 plus 0 is -5. -5 times -2 is +10. Yay, so your remainder is 0. Okay, so what we would say is, since r equals 0, x plus 2 is a factor. Okay, so it is a factor of p of x. Okay, and then even though you don't have to write this answer out, if you're doing this with synthetic division, okay, and you get something like this on your homework, this is a number, this is x squared, this is x cubed. Your final answer would be 3x cubed minus 5. Okay, if you were doing that with synthetic division. Okay? All right, so that is all you are doing for this one. Can you guys see tomorrow what we're going to be working on? What by grouping? Yeah. Okay, so your homework just has two parts to it. So from 3.3, you're doing page 170. The 6 through 12 are the evens. 20 through 28 all. 46 and 48. And then from 3.4, you're just doing 1 through 3 and 17 through 19. Okay, and I'm going to give you the rest of the time to work on that.